Dear students, first unit last topic is principal planes and principal stresses. The plane which has no shear stress are known as principal planes. Hence, the principal planes are the planes of zero shear stresses. These planes carry only normal stresses. The normal stresses acting on the principal planes are known as principal stresses. There are two methods to find out the stresses on the oblique section: analytical method and graphical method. Analytical method determine stresses on oblique sections. The following are the two cases will be considered for determining the stresses on oblique plane. A member subjected to a direct stress in one plane. The member is subjected to like direct stresses in two mutually perpendicular directions. Shown in figure, a member is subjected to the direct stress in one plane. Okay, in this plane, the rectangular member of uniform cross-sectional area A of unit thickness, let B the axial force acting on the member, is the area of cross-section which is perpendicular to the line of action of force. The stress acting on the x-axis is equal to load divided by area, hence the member is subjected to a stress along x-axis. Consider a cross-section AF which is perpendicular to the line of action of B, and the force acting on the section AF is equal to EF into 1 equal to A. Therefore, the stress of EF is given by force divided by area of EF. Such that area of FG is equal to FG into 1. Therefore, the FG is AF divided by cos theta into 1. Okay. By taking the triangle EFG, you can find out the theta. It's opposite side by ups. By using cos theta, it is adjacent side by hypotenuse. Therefore, the stress on the section FG is equal to force divided by area into cos theta. A member is subjected to like a direct stress in two mutually perpendicular directions. Second case, in the figure, it is clearly noted that the rectangular bar ABCD of uniform cross-sectional area and of uniform thickness, the bar is subjected to two different tensile stresses. Let FC be the oblique section on which the stresses are to be calculated. This can be done by converting the stresses sigma 1 and sigma 2 into the equivalent forces. Then the forces will be resolved along the inclined plane FC and perpendicular to FC. Consider the forces acting on wedge FBC. Okay. These are the representing letters. Therefore, the tensile force is equal to sigma into area of particular section. When we solve the wedges, we can find out that the force is equal to total force normal to the FC, which is equal to component of force P1 normal to the section FC plus component of force P2 normal to the section FC. Simply P1 cos theta plus P2 sin theta. Finally, we can get the resultant force is equal to root of sigma square n plus sigma square t. Okay. The angle made by the resultant force, the normal of the oblique plane, is known as obliquity. As shown in figure, mathematically it is denoted by tan pi is equal to sigma t divided by sigma n. And minimum shear stresses, the shear stress is given by sigma 1 minus sigma 2 divided by 2 sin 2 theta. The shear stress will be maximum when the sin 2 theta is equal to 1 or 2 theta equal to 90 degree or 270 degree. and theta is equal to 45 degree or 135 degree. Next, principal planes. Principal planes are the planes on which the shear stress is 0. To locate the position of the principal stress, the shear stress should be equal to 0. A member subject to simple shear stress as shown in figure, and by using the same relationship and resolve the inclined forces to vertical and horizontal, sigma n is equal to tau sin 2 theta and sigma t is equal to minus 2 cos 2 theta. Okay. Then the position of principal stresses, the position on which the shear stress is 0 are known as principal planes, and the stress acting on the principal plane are known as principal stresses. By using the triangle formula, use Pythagoras theorem, we can find out the minimum shear stresses and maximum shear stresses acting on the body. Okay, these are the this is a numerical problem. The stress acting on you at a point is mutually perpendicular 120 millimeters square and determine the length. Okay. It is the principal stress problem. Write the given data and draw the diagram carefully and find out the normal stress, transition stress and resultant stress by directly substituting the values in the formula. Okay. Do all the problems. Okay. Thank you.